All right, so let me greet you guys once again. So good morning, and as I said, we are going to be meeting online. Maybe six, not that maybe 6 times. Okay, so today is going to be our first time. Then we'll try to meet either tomorrow or Sunday. Then the rest of the 4 times we'll spread it in the subsequent weeks that are coming or that are coming. So either next week or next 2 weeks, we can spread two, and we can catch up with all the things that. We missed that I couldn't meet you guys online. So this recording, please, anybody who will watch it, kindly make sure you take your time because, as I said, I've already done setting your questions. Your example, I've submitted it. Okay. So what is left is for me to start giving you guys homework in related or similar to the exam question, but I won't give you the exact same thing, but I'll give you similar things for you guys to go and practice. Make sure you do it. Homework, I'll take it because I'll need continuous assessment. So when I send you guys the homework, I'll take it when I meet you guys Thursday. So kindly make sure you do it. So if today's own is going to be fuzzy, either tomorrow or Sunday, cardiovascular mechanics will also give you homework to do. But I don't know whether I should even allow you guys to write mid-term or I should just use continuous assessment only. I mean, to assess you guys because you don't have time. Okay. All right. So last time we learned a lot about fuzzy, and I know I sent a slice, so I don't think you have forgotten anything. So we also learn about certain basic operation with the crisp or the classical one. Okay, and as I said, in fuzzy we have these things too as well. But how do we represent these things in fuzzy? Okay, and that is what we're going to talk about today. It's quite a lot, but I pray you get a concept well. Please, if you have any question, you can uh, let me know. Raise your hand, or you can mention my name. Okay. If you are not getting any concept too as well, you can also do that. All right. Benedicta, where are your female friends? Hmm?
Said this, I don't know.
You don't know. Hey, but I hope they are all aware. I don't want anybody to go and
Yeah,
see. Okay.
yeah, if you put it on the page, so everyone is aware.
Okay, that's fine. Because one thing about students is, when you see that the lecturer didn't see anything and all of a sudden we are having this. I don't like it. All right. Okay. So let's start from here because that's where last time we got to. So let's start from here. All right. So fuzzy set theory and operations. Let's start from there. Then we can build it down there. Okay. Now, you remember in SHS and even GHS, we learned about some operations with regard to set, right? So what you were doing when we were in SHS mostly was classical. That means you find the union, you find the intersection, you find all these things. Okay. In fuzzy theory, we also have the same thing. But how it is done is a little bit different. Okay, it follows the same principle, but it's a little bit different in terms of what how it is done. But the union, the difference, and uh, the intersection and the complement, we apply the same thing over here. Okay, but the only thing is what because now we are talking about what the degree of what membership or the degree of what truthfulness or truthness. So we are going to use what certain things like what probability things. That means if it is one, that means it's what 100% a member. If it is zero, it means not. It's 0% not a member. Or sorry, 0% a member or not a member completely. If it is 0.5, it means it's partially a member and partially not a member. All right. So the same approach that we use in the classical sector, we're going to use the same thing, but the only thing I want you guys to pay attention to is how it is done. Because in the exams, you have questions based on this. All right. So we've seen this. Okay. These things. So here, a member or element of operator, not an element, not equal to equality. Okay, this is telling you it's a set that's not empty. This is a fuzzy subset. Okay, and this is a membership degree or a membership function. So you'll be seeing this a lot. Degree of membership. So the degree of membership. So degree of membership of S in F. Okay, I will talk about them. Okay, so we just have to note the notation. Okay, let's get to know the notation. The notation that is very, very important. If you know or if you understand the notation, is like mathematics. Mathematics, I was even surprised when at the higher level, mathematics has nothing to do with numbers. Most of the time, they are all what? Notation, notation, notation. Okay, that is what we use to explain certain concepts in math. So the same thing over here. Let me chip this one in. Was it last week or last week? Yeah, when I came to campus, I met Dr. Barnes, and he said now your course has now moved from uh, biotechnology in technology, whatever in engineering, to uh, uh, oh, a network. What is happening? Oh, again. All right. So as I said, I met Dr. Barnes, and he said your course is now no more technology something something, but now it's now engineering. So that means I need to start adding the math. He said I shouldn't throw the math away at all. I need to incorporate it. So please, we are going to. Should I take you guys again level 400 in any math related course? I mean, you are going to see the math. Okay. So kindly take note. Okay. But from henceforth, I won't throw the math away. I mean, show you guys the math. So kindly take note. Okay. So we've seen all these things before. Okay. Subset of, I mean, container or containment, superset, empty set, all these things. Okay. This is complement. Okay. The complement of a fuzzy subset. Right. So I gave you guys something like this to do, and I remember we did it in class. Okay. So I'm not going to waste time. So let's move on. All right. So here, when you have your superset, normally called the universe of discourse. Universe of discourse. Okay. So in classical set, we call it the universal set. But in fuzzy system, we are seeing the universe of discourse. That is the superset or the universal set. So we have two subsets from our universe of discourse. One of them talks about tallness or tall people. Another one talks about blonde people with blonde hair. You know, blonde hair people. Yeah. So now when we have uh, people, okay, which they are part of our universal subset. Okay, can we talk about some of these features, which is the degree of tallness or the degree of what of blondness? So we have a set over here, which is a subset of our universal set. So we pick John or Jean, then Marie and Pierre and David or Stephanie. So this is going to be our uh, set, okay, that or a subset that we are going to talk about. Okay, so if you take John, when you talk about degree of tallness, okay, I mean John is what 90% tall, Marie is 70% tall, Thierry is what 80%, David is what 60%, and Stephanie 60%. Here we are using what fuzzy. Why are you using fuzzy? Because we said that with fuzzy we talk about degree of truth. Okay, we talk about degree of truth, but in classical we use the term that we need a threshold to be able to know those who are tall and those who are short. So if you are in a fuzzy world, you can't say that somebody is tall, okay, because and it's going to be relative. It's not is it objective or yes, it's going to be relative. So we talk about degree instead of what being objective, whatever you are saying, that all those who are, I mean, above this measurement is supposed to be considered as tall people, and those below this supposed to be what short. But no, in fuzzy we don't use objectiveness, we use what subjectiveness over here or relativeness. So here when you come to blondness also, you also specify the degree of what blondness by saying that Jean is 0.5 or 50% blonde, Marie is 90% blonde, and Thierry is 70%, David is 40%, Stephanie is what? Is zero. So if Stephanie is 0%, it shows you that what? Stephanie hair is not, it's not blonde. Okay? Stephanie hair is not blonde. That means it's a different color altogether. Whether it is Hispanic, I mean they have different hairstyle. So when you see 0 over here, that means it's not a member of that subset. It's not a member of that subset. Okay, so the subset that you are considering, if you find the degree of membership and it's 0, it means it's not a member. Okay, it's not a member. That means I'll use the term is far away from it. It's very, very far away from it. Very, very far away from it. Okay, you can stop me if you have a new question. All right. So here we said a fuzzy subset P may be written using the notation. So you'll be seeing this a lot as we go on. Okay, you'll be seeing this a lot as we go on. So say P is a fuzzy subset of X, okay, which is a universal discourse. It composed of elements small of this. So here we are considering the subset of our universe of discourse. The subset of our universe of discourse. Okay. Now you'll be able to get this when we start talking about some examples. So let's look at this over here. So this is our subset for Tor. So subset for Tor. So I did explain this. So here, look at how it is written. So 0.9 Jean, 0.7 Marie, 0.8 Pierre, 0.6, and look at it. We are adding it. Have you seen it? This is how it is written. Then look at the blonde. 0.5 Jean, 0.9 Marie, all the way to the place. So here we are adding. Okay. So here we are considering the subset of tallness, which is over here. Considering the subset of what? Blondness, which is what? Over here. So look at how we express it. Okay, look at how it. So when I give you, we'll talk about, there's an example down there. So when I give you any table or anything that talks about some of these things, you're supposed to put it like this for me. Okay, supposed to put it like this for me. Okay. So when I ask you to give me the subset of whatever I'm looking for, the subset of whatever thing I ask you, okay, in a fuzzy way, this is how we put it. You see examples, so kindly take note. Okay. So there are certain properties. I think we have about 14 of them, if I'm correct. We are going to talk about them as all of them today. Then if you have time, we can move on to week 3. If not, then I'll pause here. Then we'll take week 3. Week 3 is very, very short. It's not anything. Okay. Week 3 will set the foundation for things like a neural network and genetic algorithm. But it's very, very short. So maybe we can use one meeting to complete that. Okay. But as I said, some of them, if you have to have a demo in class, I will tell you guys to bring your laptop. But if not, I'll do the demo online. Then I'll share the video with you guys for you to practice. All right. So the empty, you know what an empty set is, right? It doesn't contain anything at all. Okay. So empty set doesn't contain anything. So the same thing, when we say an empty subset, I mean, you see the symbol that tells you that word. And so when a subset is empty, it is only if and if for all the ordered pair. Now remember the ordered pair. Let's go back so that you see the ordered pair over here. It's talking about this is the ordered pair. These are the ordered pair. Okay. So Jean, which is what do I put it? The member and the degree of membership. 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 That is the ordered pair. Okay, so we are considering the member and what is the degree of membership. So that's the ordered pair we are talking about. The ordered pair we are talking about. So we are saying that if it is empty, the ordered pair, which I have this and that. So here is talking about the member, this or the degree of membership. If you look at the labeling, you see there are two different things. This is 1, this is 2. So it tells you that this is different from this. They are not the same. Okay, so this is the member, this is the degree of membership. In P, okay, where the degree of membership is equal to 0. So if the degree of membership is equal to 0, then we can say that what? That is an empty. Okay, that is an empty. So here, let's come here. So all the ordered pairs. So let's come here. So if we come here and we see that the degree of membership for Jean is 0, Marie is 0, for the tallness, Pierre is 0, David is 0, Stephen is 0. That means this set is going to end up being what? An empty set. He's saying that all, okay, the ordered pair, the degree of membership has to be 0. It has to be 0 for us to consider it to be what? An empty set. So if any of them I mean, happens to be any other value apart from 0, which is between, let's say 1 and let's say 0.1, that means it's not going to be an empty. So if here is 0, this is 0, here is 0, but here is 0.1, here is 0, remember the set will not be an empty set. So that is what he's trying to explain over here, that all the ordered pair. So if you take all the ordered pair, if the degree of membership is equal to 0, that means for all the ordered pair, that means it's what? It's an empty set. It's an empty subset or empty set, any of them. Okay. Then we also have the size. Okay. Remember we learned about cardinality, right? The cardinality of a set. Okay. I hope it's still in your head. All right. So when we talk about a size, we are talking about the members, okay, which will have the degree of membership not equal to 0. So that means if you are talking about the member, we are talking about all the if you are talking about the size, we are talking about the members whose degree of membership are not or is not equal to 0. Okay, so if you come to this place, which we have over here, you see that Stephanie is having what? Degree of membership equal to 0. So if I'm going to consider the size of the blonde, the subset blonde is going to be 4, because the degree of membership for Stephanie is equal to 0. So I can't include Stephanie in the size. It is not part. So it's supposed to be 1, 2, 3, 4. Only 4. Only 4. Okay. And that is the explanation given over here. So the size of subset P is the number of ordered pair in P for which the elements, which is the degree of membership, is greater than 0. Or it's equivalent, this one. Okay, the degree of membership over here is greater than 0. So the degree of membership is equal to 0. Okay, then we can consider as size 1. But if any of them is equal to 0, that one will be excluded. To be excluded. Okay. All right. Then we are talking about equal. Okay. So when we say two, I mean subsets are equal. Two subsets are equal. So when will you know, or how will you know that two subsets are equal? So two fuzzy subsets P and R are equal. Okay, if and only if for each element. So here we are talking about the member of X. Here the degree of membership of what? X. In P, there's another element which we also have over here. Here is, here is supposed to be 1. I made a mistake. Let me change it. Okay. Okay, thank you. So you can't hear me? My mic is not awful. Guys, can you hear me? Someone say you cannot hear me.
We can hear you.
Please then check either you refresh your how do I even say it? You refresh your browser. Okay, it will be from your side. It's your network. It's your network. So try to refresh it. Okay. All right. Okay. So here I was saying that. So here we are considering what? Two subsets P and R, and each one has a member and a degree of what? Membership. So if you are taking P, let's assume this is for P and this is for R. So you say that if they are equal, then that means definitely the members has to be the same. The degree members also has to be the same. That's what you're trying to say. Sorry, the degree of membership has to be the same. The members has to be equal, then the degree of membership has to be equal. If you look at how they are equating. So this is the member, this is the member. So if the member is equal to the member, and the degree of membership of X is equal to the degree of membership of the Y, that means you see they are equal. Okay, they are equal. So apart from that, so here if you look at it, I mean this is John, but let's look at the degree of membership. Okay, here the degree of membership different, degree of membership different, degree of membership different, degree of membership different. So you can see, yeah, okay, it's different. Okay, so they are not equal. It's not equal. All right. I don't know if you get the concept here. So this is not equal because you can look at the members. The members are the same people we are talking about. Okay, but if you look at their membership, okay, here all we are talking about tallness, here we are talking about blondness. But let's look at the membership over here. Here is 0.9, here is 0.5. I mean, it's not the same. When you come here, here is 0.7, here is 0.4. Sorry, 0.9, not the same. Here to look at it, not the same, not the same, not the same. All right. So we see that this is not equal. But for equality, we're going to see that these things are all equal. All right. Okay. Then containment. Containment. All right. So when we say we are talking about last time, I don't know, I said something like the superset and also the subset. And I said, let me try to enable my pen so that I can try to do something small for you guys to see. All right. So there are two things. When you do something like this, A, okay, and you go something like this, B, how will you say this? Any of you can go on to tell me. How do you say this? You can unmute and tell me. How will you say this? Hello, guys. Let's be interactive. I don't want to be the only one talking. How will you say this? What I've written over there. Oh, are you guys on the call? I don't want to be talking alone. No. So let's make the class interactive.
Hello, sir.
Yes.
Sorry, my network was misbehaving.
Okay. So I said that when we have something like this, okay, we have A, then this B, this is not CO, this is so how do you read this? Oh, so we say that what? A is a subset of B, right? A is a subset of B. Now when I turn this and I write something like this, okay, how will you also say this? It's the same thing, but the saying is going to be different. So how will you say this? If this is the A is a subset of B, then when I turn it, because it's the same, if you look at it, you see the opening is facing the B. The opening is facing the B. You see the B is what? Superset of A. Superset of A. That means B is the bigger one where you can find A inside. Okay. So the containment, I just wanted to show you guys. And so a fuzzy set P is contained in a fuzzy set subset R, okay, which you see over here. So if you see that P is what? Subset or equal. Okay, so P is subset or equal. Or I can say that R is what? Superset or equal. So that's why I wanted to, get this. So when you add this, that means we are talking about equality over here. That means either it is the same thing or this is lesser than this. Or this can be found over here. So here it's saying that a fuzzy subset P is contained in a fuzzy subset R, which is over here. That means P over here is a subset or equal subset, okay, to R or of R, okay, or R is a super subset or equal to what? P. If and only if for each element, we specify the element over in P, there's an element also specified also in R, such that, okay, the members are the same and we can find this in that. That is what you're trying to say. Okay, we can find this in that. That means this one has to be smaller than this. That's the implication, as you can see over here. Okay, so the degree of membership of X, how did I even put this formula? I think this formula is wrong. Okay. You're supposed to be Y, not you're supposed to be Y. What I'm talking about is so you're supposed to be Y. Okay, I'll change before I send to you guys. So you're supposed to be Y rather. Okay, so the degree of membership, okay, of X has to be less than or equal to the degree of membership of Y. That means here I'm talking about P. That's why you can see P over here. I'm talking about R. All right. So what he's saying is that if one is contained in the other one, that means remember the one that is contained in the other one is smaller than the bigger one. Okay. So here let's look at this too. We have P. So we have T and B. If you look at it, can you tell me or can you say that? Let's look at the first one over here. Which one do you think is contained in the other one? Okay, we are looking at the set T and B. Okay, the first one. Do you think any of them is contained in the other one? Hello, guys.
Hello.
Yes. Your network is breaking, so I can't hear you. Do you think any of them? Please, you can unmute. Let's make it interactive, so that you get a concept. I don't want to talk me alone talking. What you said is wrong. I'll correct you. Okay, don't be. Mm. Hello, guys. Should I mention him? Okay, Benedicta.
Yes, sir.
So which one do you think is contained? The first two sets, the T and the B. Or yeah, the subset T and the B, because you are considering. Yeah. Which one do you think?
You're considering which one?
The one that I've this
Superset.
one. No, so we are talking about containment over here. And we say when talking about containment, that means you can have one set in another one. And I use the word subset. Okay. And we define it over here that when talking about the containment, it means one, the or the members have to be the same. So here that means the member in X1I supposed to be equal to the member Y1J. So the members have to be the same. As you can see, the members are the same throughout. Okay, so that is the first rule. The first rule is satisfied. The second rule came here to say that, okay, the degree of membership. Okay, so if I'm saying that, okay, T is contained in B, if T is contained in B, it means the members have to be the same, and also the degree of membership of T has to be less than the degree of membership of B. And I'm saying that, let's look at these two subsets, T and B. Which one do you think is contained in the other one? From the explanation I've given so far.
Okay, I think B is containing T.
B is containing T.
Mm.
Okay, who else? Caleb. Caleb.
Yes, sir.
Yeah, so Benedicta said B is containing T. What about you? What do you think?
Um, so I'm not really sure.
So tell me what I mean. Yeah, you are not sure. So tell me something because you are
So
not.
please, I'm changing my answer.
Okay, Benedicta says she's changing her answer. Okay, go on.
That B contains B.
Come again.
B contains B.
T contains B.
Yes.
Okay, so T contains B. Okay, that is what he's also saying. All right. Caleb, you said you are not sure, so tell me the unsure answer.
So I think um so I think P contains T.
You think B contains T? Okay,
Yes, sir.
so B contains T. Okay, the last person, uh, Henry. Henry, yeah. Oh,
T contains B.
T contains B. Okay, I want the last person, Isabella. Isabella, are you on the call? Okay, so T contains what? B. All right, so I've heard you. Okay, so you are all wrong. Okay, so Benedict, I thought you saw the correct thing when you came to see. Now, if you look at it, yes, if you look at the T carefully, you assume that, or you are thinking that T actually contains B, or B is contained in T. No, let's look at the Marie. If you look at Marie, you see the rule breaks over here. Look at the Marie value. The rule is going to break. Because if you are saying that T contains B, okay, then that means here has to be greater than what? The 0.7 has to be greater than 0.9. So we have to flip it before T can now contain B. I don't know if you've seen it now. So if you look at the Marie, okay, that rule break because we are seeing that the degree of membership has to be less than, the lesser one. So T cannot contain B because, and B also cannot contain T. So it's neither of them. Okay, so this is it's an open thing. So that means this side, there's what? The rule broke. Okay, or yeah, the rule, there's a break over here. So because of that, you can't see that T contain B. Okay, I don't know. Have you seen it now?
Yes, sir.
Okay, so let's look at the last one. So which one? If you look at the last one, how will you put it? So the last one, which one contains the other one, or which one is contained the other one? So anybody can go on to answer.
But T contains B.
All right, so T contains B. That is correct. Because if you look at it, the members are the same, and if you look at T, all its memberships, okay, the membership values are greater than what? That of B. So we say what? T contains B, or B is containing T. B is containing T. All right, so that is that for the containment. Any question before I proceed?
So please, I didn't get well for the first one.
Okay, so the first one, if you look at it, look at the Marie, okay? The Marie is 0.7 for the membership, okay? And when you come to the B, the set B is 0.9. And we say that for the containment, if you look at the degree of membership, okay, that means one of the subset has to have what? A higher value for all the degree of membership, okay, for the than the other, or greater than the other. So here, if you look at the T, here is 0.9, but here is 0.5, which is true. When you come here, it's 0.7, 0.9. But so apart from what I've circled, the rest for the T, they are all greater than what? That of the B. So that is why they were saying that T contains B. But it's not true because at the Marie part, if you look at the Marie session, okay, it's supposed to be the other way around, which is supposed to be the 0.9 has to be here, the 0.7 has to be here for the T to contain B to be true. But because here is 0.7 and here is 0.9, it means T cannot contain B, and B also cannot contain what? T, okay? So because of that, is neither, okay, or neither of the two, okay? That means it's open. If I say it's open, it can T cannot contain B, B also cannot contain T. So that is why I circle this place. But when it comes to the second one, you see that If you check the T, look at the degree of membership for all the T. They are all greater than all the degree of membership for the B. So we will say that T contains B, or B is contained in what? In T. Okay. Yeah. Are you okay?
Yes, sir.
All right. So let's move on. Okay. Then the union. Now, please, let me say this so that in exams you're going to see this. In the exams, this is how I set your question. Okay. Please, you're not going to see this. I'm not saying the two of them. This is wrong, but this is what I use. These are the notations I use in the exams. So kindly take notes. So let me say it first before I forget. In the exam, these are the notation I use. So kindly take note. It's the same thing as this. Okay. All right. So union, in classical one, what we do when I ask you to find the union, you try to sum the members in each group, right? And those that are repeating, we just keep one, or we take only one of the repetition, and those that are not unique, you add everything together. So the union is something that you're not going to waste time. Okay, but how do you do it in fuzzy? Fuzzy, how do we do it? So when you talk about union, okay, in fuzzy, we are trying to talk about the maximum value, okay, in the two subsets. So when we take the two subsets, we want to pick the maximum value. We want to pick the maximum value. Okay, so the union of two subsets P and R, which is written like this, okay, is defined as the fuzzy subset of ordered pair. I've already explained the ordered pair, right? So this is the member, and this is the degree of what membership. Okay, formed from all the ordered pair. So he's talking about all the ordered pair. So here, if you are dealing with 2 or 3 or 4, so you have to know that here, all this while you've been dealing with only 2 subsets. Can it happen you can have 3? Can you can have 4? Yes, it's possible we can have 4 subsets or 5 subsets or even 3 subsets. All this while, it is only 2 subsets we've been dealing with. So the ordered pair, as you have been seeing, I showed you over here, which is, what is it? So these are the ordered pair he's talking about. So we order the member and the degree, the member and the degree of membership, the member and the degree of membership. All right. So he said the union of two subsets P and R is defined as the fuzzy subset of ordered pair. I've already explained it. Formed from all ordered pairs. Okay, that means your subset at the end is going, so your union is going to be a subset, but it will be an ordered pair. That is something I have to say. Your union that you are going to get, the answer of your union will in turn be an ordered pair. Okay, will be an ordered pair. So he's saying a subset of ordered pair, which is this, formed from all ordered pair, this and that, in R such that. So what he's saying is that the members have to be the same. The members have to be the same. So if you are considering Kofi in set 1, you have to consider Kofi in set 2. The members have to be the same. So you can't consider Kofi in set 1, and you are now comparing to Kwame in set 2. No, that is wrong. So he's saying the members have to be the same. And the degree of membership, we pick the maximum one. The maximum means you pick the greater value among the maximum, the degree of membership. You pick the maximum among the degree of membership. So when the union of 2 or more pairs is performed, the result is also what? An ordered pair. Please don't forget this, because when I ask you, or when you see it anywhere, not even in exams, okay, when you see it anywhere, the union, because you are dealing with fuzzy, the union has to be what? Ordered pair too as well. The first pair, okay, has to be the member, and the second pair has to be what? The degree of membership. And that one is gotten from the maximum, okay, the maximum of the memberships that you are dealing with. The maximum, you pick one. All right. So the first member of the resulting pair is the type of the comprising entities within the fuzzy subset. So we're talking about the entities or the member. It's the same thing. Either here what entity or the member. And the second one, which using the max operator, is the largest grade of membership or the degree of membership of two or more of the comprising entities. I've already explained this. Is it clear before I move on to an example for us to get a concept? Is it clear? You can give me a reaction, a thumbs up for me to know that you guys are okay with the explanation I've given so far. Okay. So let's take an example. All right. So this is an example. Let's look at it here. So here I have two subset T and B, and they ask me to find the union. Okay. So as we said, the entities or the members has to be the same. So if you're dealing with Jane, here has to be Jane for Marie, like that. Okay. Then we now come and consider the degree. So here, if you look at it, this is, the approach or the calculation or the steps that you follow. So here we take the Jean, then the maximum between this and this. Marie, maximum between 8th degree of membership. Pierre, the maximum between this and that. David, maximum between this and Stephanie. So this is our approach. So when we finish, what we do, we pick the maximum. So the maximum 0.9 and 0.5 is 0.9. So that is why you see it over here, 0.9. That's why you're talking about ordered pair. Then we go back. Marie, we pick 0.9. That's the ordered pair. So Marie and 0.9. Then Pierre, we go there, 0.8. Okay, you also see it over here. Then David, David also 0.6. So that one too, we pick it also here. Then Stephanie, Stephanie to 0.6. That one too also. So click that one also here, as you can see. So when we finish, this is how we present our answer. And I showed you this before. Let's go back so that I'll show you, those of you who joined late. So I told you this is what I expect, okay, in the exams. This is how you put things. Okay, so this is how you write your subset. This is how you write your subset. Okay, because the union is going to be a subset on its own, that is how it is written this way. Okay, that's why it is written in that way. So as you can see over here, obviously 0.9 Jean plus 0.9 Marie plus 0.8 Pierre plus 0.6 David plus what? 0.8 Stephanie. Okay. Are we okay? All right. So now how do we explain this? When you have something like this, how do you explain? This is an explanation you should be able to look at it and tell me now, oh, okay. So what is trying to tell you that we have two different subsets, tall and blonde. Yes, Isabella? I'm comparing. If you say I'm comparing, I don't get it. I'm returning the maximum. I'm returning the maximum among the degree of membership. I'm returning it. So if you look at it over here, the degree of membership, tall and blonde. Okay, I'll return the maximum, which is 0.9. Then when I come to Marie, okay, I also return the maximum. Here you are comparing two different subsets. Okay, tall and blonde. Okay, they are, I don't know if you get it. It's like I don't even know. It's like you, in a class. Okay, so in a class where we have two different classes, we have class A, class B, and we wrote a quiz, and maybe we have mathematics, science, and English. Then if you are doing the comparing, you can only compare maths in group A to maths in group what? B. That is the same thing we are doing over here. Okay, so there are two, which is two classes or two subsets. So the mass over here has to be the mass over there. So the same thing over here, we are considering two things, the tallness and blonde. So if I take John, okay, how tall is John? How blonde is John? That is what we are trying to do. So it's the same thing, but two different properties, okay, which is tallness and blonde. So what we do, we pick the maximum out. So when you get your final answer, this tells you a lot of things. The first thing, it tells you that indeed John is tall. Okay, the guy is tall because That means tallness is what? Conspicuous. It's something that is more dominant, okay, in John instead of what? The blonde hair. I don't know if you get where I'm coming from.
Okay.
Aha. Because we are picking out the maximum, which is the most dominant uh, uh, feature or property that you are interested in. When it comes to Mario, also the same thing all the way. Okay, so if you compare them, you see that oh, some features are dominant in others than what. Uh, so, for example, I think when it comes to Marie will be more blonder. I don't know whether it's the correct English. Marie will be blonder. Okay, so when you are comparing blonde, we should actually consider Marie because he will be more blonder. Because if you look at it, he's going to have what the maximum for that. Okay, yeah. Are you okay?
Simply that.
Yes, sir.
Okay, yeah. Adam, go on, ask your question.
Maybe can there be a situation whereby we have different members? Then if we have different members, how do we go about it?
Different members, like if you say different members, you have to talk about the same property. So, for example, I can, you, Adam, Benedicta, Isabella, Henry, you are different members. But whatever feature that I'm dealing with, if I'm talking about tallness, I have to use tallness for the four of you. Then I can talk about maybe complexion, dark skin or fair skin. Okay, I also have to talk about the features that I'm interested in. It has to run through all the members. So I don't know if I've explained it or maybe you meant a different members.
Yes, sir. I get it.
Uh-huh, okay. All right. Okay. So let's talk about intersection. So intersection is opposite to a union. So the same explanation I gave in the union, but the intersection we are going to retain the minimum. We're going to retain the minimum. Okay, we are going to retain the minimum. That is what they have in common. So the explanation I gave in the uh, the union, okay, just transfer the same thing. But the only difference here is what you are retaining what the minimum. You are retaining the minimum. Okay, why? Because it's just like we say that one can be found in the other. So I don't know in Chi you almost say ɔfa ne papa kakra na ɔfa ne maame kakra na obi ga say we do ɔfa ne maame more but we kitikiti wɔ ne papa. That is the same like intersection. Okay, so for example, if you compare the 0.9 and the 0.5, okay, you see we are taking the minimum, so the minimum is going to be 0.5, right? But can you see that we can find 0.5 in what? In also 0.9. It's like the containment. Okay. But the 0.9 is more. That is why initially I said tallness will be dominant in John. Okay. That doesn't mean that blonde is not in John. Blonde is in her. Okay. But tallness is going to be more dominant. So the intersection is what they have. So we are going to pick the minimum. So this, we are going to choose this. Here, we are going to choose this. Here, we choose this. Here we choose this, and here we choose that. Okay, for the intersection, as you can see over here. Okay, so here that one too. Please learn how to present your final answer like this. So once you get your thing like this, you put it in this format. Okay, put it in this format. So the union takes the maximum of the degree of membership. The intersection takes what? The minimum. But make sure the members, you are talking about the same member or the same entity. Any question? Yeah?
No, sir.
All right, so let's move on. Right. So negation, this is, if I negate something, you normally subtract it from 1, okay? So that is the same thing like, I don't know, is it complement? Because it's not part of it. Okay, so negation or complement of a fuzzy, okay, subset P, which you use this, or you can also see this formula to as well, is the set of all ordered pairs such that for all ordered pair, okay, in P, the elements which we are talking about the entities, Okay, the degree of membership is the degree of membership over here minus 1, or 1 minus the degree of membership over here. I don't know, let me take it again. So you first consider your members, then we now consider the degree of membership. So if you want to find a negation, our interest is the degree of membership. So take the degree of membership, subtract it from 1. That's going to find the complement of that member or that entity. Okay, and as you can see over here, this is how you find it. All right. So if I want you guys to find the complement of T, okay, can you guys help me out? Let's find the complement of T right now. How is going to be?
So we are going to get 0.1 for
0.1, okay, Jean. All right, I'll use the initials plus.
and you have 0.3 for Marie.
So 0.3, okay, Marie M. All right, plus
0.4 here.
0. What?
2.
0.2, okay, 0.2. All right, then Thierry.
0.4 for David.
0.4 for David. All right, so D, and plus the last one.
0.4 for Stephanie.
0.4 for Stephanie. All right.
So
All right.
for the G, 0.1. Who's the 0.9?
Oh, okay. Sorry. Let me delete it. Where's my eraser? Okay. Oh. Hey, where's my eraser? I can't find my eraser. Hey, I don't want the eraser. Okay, so 0.1. Let me make it 0.1. Okay, so 0.1. All right, so that is that for the negation. Okay, so as you can see over here, I mean, that is that for the T. Okay, and this is also what for the blunt. Okay, so this is straightforward. Okay, so if you want to negate it, find the negation, just you keep the members, but you take their membership and subtract it from 1. Okay, are we okay here also?
Yes, sir.
All right, so let's move on. Okay, all right, so there are certain properties. So what we've discussed so far, these are operations. So the union, intersection, the complement, the containment, these are all equal, they are all operations. Okay, now but there are certain properties we have to talk about. Okay, this you've seen them also in how do I even put it, normally in sets and other areas such as my network. Can you guys hear me?
Okay.
Okay, I thought my network was going off. Okay, so here let's look at this commutation. Okay, so commutation, is that the way did I even spell it right? Commutation, yeah, commutation. All right, so here, I mean, that means if I find a union between the two, so it doesn't matter if I mean, flip it, it's the same thing. Here, I'm not going to waste time. Okay, and I didn't ask you guys to prove any concept, but in example or something I can give you guys to try, I can ask you to prove this. So what do? You just have to interchange it. So if you start with T union B, you just have to go B union T, and to give you the same thing, commutativity. Then associative, as you can see, so we find a union with one, then after that we come and union with the other one, or we do the yes.
Sir, please, I didn't get the commutation.
The commutation, so for example, let me do the mathematics one. So 4, okay, plus 3, it doesn't matter if you turn it. 3 plus 4, won't you give you the same thing? Yes, 7, right?
Yes, sir, you
It,
get
so the same thing over here. So he's saying that whether the you have the first subset, so let's assume this is T, which is the first subset, this is the B, which is the second subset. if you flip it, that means if you interchange it, it has to be the same. Okay, it has to be the same. So A union B is the same thing like B union A. If intersection also has to be the same, if it is what? Commutation. Okay, so if you flip it, it has to be the same for that. Then the associative, okay, the associative one, it depends on you, okay. Either you group them, so you're going to group two. So if you start with the first two, find the union, okay. Then when you get the answer, you union with the third one, or you take the last two, find the union, and you union with the first one. The same thing goes also for what? For intersection, as you can see over here. So we can find the intersection for the second, which is the second and the third. Then after that, we intersect it with the first one, or we find the intersection between the first and the second. Then after that, we intersect with what? With the third one. Okay, so it all depends. So when I give something like this, you are just going to do the arrangement. So if you look at the process, what we went through, just what you arranging it. So maybe if I'm doing B, okay, if I'm doing B intersection T, that means I'm going to flip this one. Here is going to be what? 0.5, right? Then 0.9. Okay. Then here to become what? 0.9 and what? 0.7. All right. So it's just you flipping what? The degree of membership to tell that this one is coming first, this one is coming last. All right. And we are saying that if it is commutative, it has to be the same. Okay, doesn't matter the flipping. All right. Then distributive also is also here. Okay, so we say that the union is distributive over the intersection. Oh no, the intersection is distributive over the union. So here, if you take this, we connect with this, like you are expanding the bracket. So here you expand it, so A union B, as you can see over here. Then you take the same A and use it on the C, A union C, then the intersection over here. All right, so you have example also here. So here I did for the union, the same thing. So here too, it can be here, as you can see. Then this one also can be here, as you can also see over here before this. Okay. All right, so as I said, I'll be sending you guys some practice work and also homework to submit. So, I mean, you see that. Okay, so I've already spoke about the complement, which is the negation, which is the same thing as you can see. So I'm not going to waste time, okay, because you've already spoke about it. Negation and complement, the same thing. All right, negation and complement, the same thing. So here we just have to subtract. So here we subtract this from 1, we get 0.9, subtract this one also from 1, 0.3, subtract this one from 1, 0.8, subtract this one from 1, and subtract. So that's what? Complement, you're finding the complement. Okay. Then what about the difference? What about the difference? Okay. So the difference, last time we learned that when you say A, okay, difference B, what is the meaning? What's the meaning? What's the meaning? So last time I said that what you do, if it is ordinary set, you just have to cancel all the elements you have in B that is in A and return the A. That is what I said, right? Correct me if it's wrong. Okay. All right. So how do we also do that also in fuzzy? So here, look at it. So if I ask you to find A, the difference of A and B, okay, look at how it is written. So it becomes the A intersection B complement. A intersection B. That means you have to first go and find out B complement. You need to go and find it. Without getting B complement, you can't find it. So you need to go and do that calculation. So here we have to calculate B complement, as you can see over here. And how do you find B complement? We subtract. So if you come here, subtraction will be done. Okay. So once you have your subtraction, which is 0.5, 0.9, this, then we now find the intersection. And we say the intersection is supposed to what? Return what? The minimum, right? So here, yeah. So here this is our A, this is our B. You find the intersection. So here, if you look at it, you're going to find the minimum 0.5, which is here. You find the minimum 0.1, which is here. You find the minimum 0.3, which is here. You find our minimum. So this, they are the same. So you have to select one. So if they are the same, we select one. So 0.6. Then here you pick 0.4. So don't forget to write your answer in that format for me, where you're going to put your here 0.5, right? Then this, then Jean, like that. Okay. So don't forget to put your answer in that format for me. It's very important. Are you okay with the difference? If you have a question, you can go on to ask. Okay. All right. Then we also saw the De Morgan's law. De Morgan's law. Okay, so let's look at De Morgan's law. So here we are finding the complement. So we find A union B, then the complement. The same thing like the complement of A intersection or the complement of B. And I said find a way to memorize this, okay, so that I don't forget. Then here, if you find A intersection B or complement, the same thing like finding what A complement C union or B. So if I ask you to do any calculation, it's just simple. What you have to do is just step by step. So first, what you have to do is you need to find the union of this. Once you get your union, before you can go and find a complement. So I don't know whether I have an example over here. Okay, so we take one. I think we can pick this one. All right. So here we find the union, A union B. So A union B, as you can see over here. So you're going to return this. Then you're also going to return this. You're also going to return this. You're also going to return this and that. So as you can see, that is what the person returned over here. So here I'm going to return this, return that, return that, return that, return this. Okay. So once you are done with that, okay, then you can now find a complement. So we find a complement. Since you are returning 0.9, you find a complement, get 0.1. Since you are returning 0.9 again, here has to be 0.1 for the complement. Here you are returning 0.8, so here is 0.2 for the complement. Here you are returning 0.6, 0.4. Here you are returning 0.6, so 0.4 for the complement. So that is that for this side. Then we are now going to prove this side also. So this side, how do you do that? We need to find the complement of what? Of B, and also the complement of C. Sorry, the complement of A, and find their intersection as well. So here we find B complement, which we do the subtraction. Then we find what we also find A complement. I think I didn't show that. Okay. Oh no, I'm lost. I'm going the wrong way. Okay. So we find A complement. We also find our B complement, and after that, we find the intersection, which if you return it, you are going to get this. Okay. All right. All right. So either you leave it. Okay. So you leave it in the form I told you guys to do that for me. All right. So please, any question? Any question for me? Let me see. Wait, so I have some about 13 slides to go. Any question? Please make sure you are clear. Okay. Make sure you are clear. All right. So if you guys are okay, then let's move on. All right. Now, because remember SHS, we try to draw things to explain sets, right? So you see this. So this is the classical one. But how do you do that in fuzzy? We also have ways that we can represent our set graphically. Okay, and how do you do that? So all the things that I spoke about, whether it's union, whether it's intersection, whether it's complement, okay, whether it's a member, we cannot express all of them, okay, graphically. So this is telling you that what membership function of fuzzy set A. Okay, that means we are talking about can say Jean is a member of our Tor or Torness. So that's a member. Okay, that's a member, as you can see over here. So it tells you that we'll talk about the two axes. I'll explain it. So we'll call this one the domain, and this one is what the degree of membership. So the degree of membership, you see the minimum is 0, the maximum is what? Is 1. It goes all the way to the top over there. Okay, so anybody can be within this range. You can't go outside. The domain is the designer's perspective, the designer's choice. You specify your domain. Now let's look at the union. So if I have 2, okay, so I have 1 here, then I have another one also here. So if you should draw it, you see what is their union. Okay, so everything here, everything here, everything here put together as a union. Okay, then look at the intersection. So what they have in common. That is why we are picking the minimum, as you can see. And look at the complement. If you look at the complement, what do you think the complement is actually doing? Look at the diagram carefully and tell me what you think the complement is doing.
Yeah, but the complement has been turned upside down.
Yeah.
Right. An opposite.
Thank you. So it's just an inversion. Okay, it's an inversion of the membership we have over here. So if you have a membership A and I want to find a complement, just what an inversion. So the same one, but I'm going to what? Invert it somewhere, something like this, and like that, and continue that way. So just an inversion of whatever you have. Okay. All right. So please, you take note of some of these diagrams. Okay. Take note because I ask you to draw. All right. So let's talk about the application. Why are we wasting our time studying all these things? It's very, very crucial because we are engineers now. We are going to build systems in the future. Okay. Definitely, we need to know how to apply some of these things. Okay. And even if you are talking to your friends, you can tell them, oh, you are talking in terms of fuzzy now. Can I model the way you are even eating all these things? You can use fuzzy approach. All right. So let's try one. We have some examples. Okay. Then some of them. Yeah, I think I'm left with these slides. Let me hurry up. I want to close exactly 1. Okay. All right. So let's assume we have 2 friends. Let's see, John and Mary. They are going to the movie. Now, when they go to the movie, they all have choices. Okay. Somebody will say, "Oh, I didn't like the movie." Another person will say, "Oh, I like the movie." That is their opinion. Okay. So that is their opinion. So we are going to take the liking and not liking as what? As our set. So 2 different subsets. Okay, 2 different subsets. So their preference is going to be the discourse. Okay, the universal discourse. So did they like the movie or they didn't like it? So liking is a subset. Not liking too is another subset from our universe of discourse. So if we want to use the crisp approach, okay, we only have 2 options. Did you like the movie? Yes or no? You can't tell me that, oh, you love the movie to some certain percentage. Oh, maybe I'll grade it 60%. If you are grading it 60% or you love the movie somehow, you are not thinking in terms of what? Crisp or classical. We are not thinking in terms of what? Fuzzy. All right. So for us to, use classical or crisp perspective, that means there are only 2 choices, either 0 or 1. That means either John didn't like the movie or he did like the movie. Or Mary didn't like the movie or she did what? Like it. So when it happens like that, how can we represent it? Now, we can do that using this diagram. Okay. So we have didn't like, which is 0. Like means 0. So this is John. This is what? Mary. So if I'm looking at the subset of like, okay, they went to see the movie. I'm looking at the subset of like. That means we can have a situation where they didn't like it. So 0, 0. So John didn't like the movie. Mary also didn't like the movie. Or John said, I don't like the movie, but Mary showed interest. Okay. Then the same thing. Now, if you look at this diagram, what can you see about this diagram? It has 2 corners. Sorry, 4 corners, not 2 corners. 4 corners. What is so unique about the corners? Now, if I'm moving from this corner to this place, you tell me, say, the distance is what? Is 1. Do you see that? If you want me to find the distance, it's 1, right? if I'm moving from here to here, you want to find a distance. The distance to is 1. If I'm moving from here to here to the distance is what? It's also 1. Then from here to here to the distance is what? It's also 1, right? Okay. So this is trying to give you something like a discrete step. Discrete. That means we can move from this place all the way to what? To here. You can have interval. That is the classical I've been talking about all this while. Okay. But mind you, systems are not like that. We'll talk about it. Yesterday, I will say that. Okay. So systems are not like that. So they can be something like a flip, or they can be some how do I even put it? A surge, an increase in the value. Okay, if there's an increase in the value, is it going to be classical or fuzzy? This is where fuzzy comes in to help for classical systems. Okay, so each one will be moving step 1 by 1 by 1 by 1. Okay, as you can see over there. All right. So here, if you want to find the intersection, you are going to determine. Oh, say the intersection is going to be what? 0 over here, right? Then what do you have? 1. So 0 over here. Then here it becomes what? 0. Then here it becomes what? 1. Because we say the minimum is 0 here, minimum is 0 here, minimum is 0 here is what? Is also what? 1. Are you okay? So here we are dealing with a classical. Now, if you see something like this, anybody who see this will tell that, oh, this is what the binary system we are dealing with, because it's zeros and ones only. You don't see any other value apart from zeros and ones. So anybody who will see this will tell that, oh, this is what? A binary system. It's a binary system because it's only zeros and ones. Okay. But, the world that we are living in, you won't get this exactly. Okay. Nature is what? Analogous. So things has to be imprecise, or things are imprecise to some extent. So what do we do? So we can say, oh, okay, I don't want to use the classical or the crisp approach. So here, look at what we've done so far. Okay. So here we try to introduce some degree of what? Of likeness. Some degree of what? Likeness. So as you can see over here, the same diagram that you saw over here, we are trying to introduce what? Some degree. Now we can even extend it further and try to do a lot of mapping over here. So from here all the way to this place. So when it happens like that, it's the same thing we are having over here, because the distance from here to here will still be 1. But this time we are not jumping. That's not a complete jump. Okay, if you are building a system, you are not going to say that, okay, you are taking all values between 0 and 10. Sorry, you are taking values, 0 and 10 only. So if it's 0, you read it. If it's 10, you read it. No. Well, if you do that, that's a classical. But you can have what? Intermediate values, such as 2, such as 3, such as 4. So how do you do that? Okay, this is what we are trying to illustrate over here. That instead of us having a complete jump from 0 to 1, that means our interest is in the 0 and the 1. No, we can also introduce some more degree of truthfulness, and we try to bring this. So here, if I'm here, that means 0.7 and what? 0. That means the person I'm dealing with. Let's assume I'm dealing with John over here. Okay. So if you look at it and pay attention to the way the diagram is. If you look at, let's come here so that you guys will see the picture well. So if you look at it, the first column here, okay, will change from 0 to 1, but this one remains. Okay. If you look at it over here. Then when you look at here too, here also will change from 0, okay, to 1, but here what remains. Okay. Now you guys have not done Boolean, so I don't know, but let's look at the table carefully over here. You're going to see something. You see, the values are alternating. So if you look at it, the extreme right, they alternate 1 by 1. So from 0 we move to 1, and from 1 we move to 0, like that. Then the one at the left will alternate twice. So 0, 0, then 1, 1. So the next one becomes 0, 0, then 1, 1. Okay, so that is what is actually happening over here. So here, if you look at whatever is happening over here, so here, here is 0, okay, then 1, here is 0, 0. So here it has to be 1, 1. Then here must be what? 0, 1 as well. Okay. So when you look at the vertical also, here it is what? 1, 1, then what? 0, 1. The same thing over here. So 0, 0, then 1, 1. Okay. So what I wanted to explain over here, okay, was just to show you that we can introduce some form of what? Degree of truthiness. So here we pick this. Here too we are picking 1, 2, 3. So we are picking what? This over here. All right. So here too we are also picking a value over here. So when we have this is actually some degree of what? Truthiness. So if you take things like the ammeter, the speedometer, I mean, they all use fuzzy things. Okay, they all use fuzzy things. Because for us to move all the way from 0 to 1, we have to move in what? In some steps before we get to 1. We can't just jump straight away from 0 to 1. Okay, you can't jump straight away from 0 to 1. Okay, I don't know if it is clear or I move on. You can ask the question if you're not sure.
Hello there. Hello there. Hello there.
Yes, Roxanne. Or make sure that I mean we race is no fan patch. All right, so let's look at this. Let's look at this example. Okay, so let's define fun being a fuzzy subset of enjoyable activities and inexpensive, okay, be the fuzzy subset of what? Inexpensive activities. Okay, so let's look at it. So I have the activity over here, then I have, I mean, the fun aspect and what? An inexpensive aspect. Now, if you look at it carefully, okay, look at this carefully, we have a degree of membership. So how fun is working and how expensive is working. How fun is movies or film, how expensive, so how inexpensive, how inexpensive. So I've specified all these things over here. Okay, so how do we put this? Now, there are a lot of things I can actually say about this. Okay, for example, we can talk about the union. Okay, the union and also the intersection. So here, the union, that is what I've done over here. So here, I have 0.9, which working, then 0.8 for the film, then 0.8 again for the theater, then like that. So this is, I can give you a table like this, and I can ask you questions based on it. Okay, based on that. So this is something simple. I shouldn't waste time. The same thing with the intersection. If you look at it, you pick the minimum. All right. So who is not clear with this example that I have over here? If you're not clear, let me know. If you are clear, so that I can move on to the next part. Who is not clear? Are we okay? Please, I want more feedback. Oh. It's only Adam who is, I mean, giving me thumbs up. The rest, what about you? Isabella, Benedicta, Henry. Okay. All right, so let's move on. All right, so the last part, the last session, then I can close the chapter on week 2. All right, so fuzzy precision our membership function. Now we need to learn how to draw, okay, some of these diagrams, or we should be able to learn how to interpret some of these diagrams. I remember I show you, okay, this diagram. Okay, how do we, I mean, get to know or learn from this? Okay, I can ask you to draw, but how do you draw it? That is something we have to learn. Okay, next week we'll talk about it. I mean, the next meeting that we'll do in fuzzy systems and control, we'll talk about it. So we've seen the expression. This expression talks about degree of membership. Okay, so we are mapping an entity to some degree of truthiness. Okay, so when you see this, that's the formula it's trying to tell you that some entity or a member be mapping to what? To some degree of membership. And we already know that the degree of membership span from what? 0.0 to what? 1.0. This time I believe we are all aware, we understand this. Okay. So the fuzzy logic membership graph follows the traditional X and Y graph format. So you have the X and the Y as he's talking about. So what does the vertical axis represent? The vertical axis represents the possible grade of membership or the degree of membership, which span from 0 all the way to 1.0. So here he's putting 1.0 over here. That's, I mean, for example, here, if he says 0, that means you are not part of it. Okay? But for you to have a degree of membership, that is why he's putting this in over here, the 0.1. But most of the time, not that most of the time, we start from 0. Okay? But because you are part of the team, that is why we are giving you 0.1. That means you are 10% part of it. But if you are 0%, it means you are not part at all. Then what does the horizontal axis talks about? It talks about the domain or the range. But that one is it is your choice. You decide. Okay? But the vertical axis, that one is the truth. We start from 0.1 to what? To 1. Or you can start from 0 to 1. Okay, that one is something that is the fact. Okay? But the domain or the horizontal axis or the range, you choose it. So let's look at this. So in Ghana, the typical age of attaining legal adulthood is what? Is 18. So when you are 18, we say that what? You can vote. You are now responsible. You can marry. Okay? When you are 18, according to the law of Ghana or the legal terms of Ghana. Okay. So we can draw a diagram, which is a graph to represent this. If you are using the CRISP or the classical approach, have you seen my domain? I specify my domain down here. Now, somebody will say, oh, I want to start from 5 years, 5, 6, 7. That is a person's domain. So the domain always is your design. So the designer, you are responsible for your domain. Okay? So somebody will start from, let's say, 10. But if you look at the domain over here, the person started from what? 12. That's the person's domain all the way to 30. Another person will say, okay, I want to start from 15 all the way to 20. You choose that. But if you look at the degree of membership, which is the vertical axis, that one, it's obvious. We start from 0 all the way to 1.0. That is something that you can't, choose any value other than what? 0 all the way to 1.0. Have you seen it? So if you look at this graph, it explains what? The classical one. How do you say? So here, it tells you that no, all these things, you are not an adult. But immediately you get to 18, there's a jump, which get to what? Adult over here. Okay, so that means from 18 all the way you become adult. So look at the difference between the two. So if you look at it, one of them talks about what? Membership, okay, which the membership keeps on changing and changing and changing. But the other one, there's what? The membership is 0 till you get to what? To the threshold, then what? There will be what? An abrupt change. Then you become what? An adult. Please, do you get it now? Any question? Okay. Yeah. Okay. So let's try to interpret some of these graphs. Okay. Let's try to interpret some of them. So let's look at it. So here, as you can see, have you seen the domain? Look at the way the domain is rising. So it tells you that as we keep on drawing, the degree of membership increases. That means it keeps on increasing. Okay. It keeps on increasing to the value of 1. Okay. That means it has to definitely reach 1. That is something that has to happen. You have to get to 1. Okay. That's to get to 1. All right. So as you can see over here, it's going up this way. Oh, sorry, I'm down. All right. So, where's my pen? Yeah. All right. So it's going up, or it can also decrease. As you can see, it can also decrease. So whether there's an increment or decrement, if it is an increment, it can go, and the maximum it can go is 1. If it's decrement, we start from 1 all the way towards to 0. All right. So as you can see from here, there are a lot of things that we can explain. For example, if you look at somebody who is 14 years old, if you draw, when you cut this place, you draw all the way. You can say, the person is 75% an adult. Okay, you can say the person was 75% an adult. Okay, till we get to 18. So when you get to 70, you can also draw. You can see the person was maybe 99.9% an adult. Okay, so look at how the drawing is done. Look at how the drawing is done. Okay, all right. So as I said, the horizontal axis, as you said, the range of values on the horizontal axis, the problem portion of the design. Okay, that means you are the one to decide that. So the problem will let you know how you come up with your domain. How you're going to come up with your domain. All right. So let's look at this. Here, it's obvious. When you get to this place, you get to what? We normally call this one a plateau. Okay, when you have a plateau, there's no change. That means that is what the threshold. Okay, so we can increase, which is the low value, and get all the way to this place. Okay, so it is this one that is going to give us the highest value. Once we get it, it's going to stay over there. The same thing can also happen with this. We can decrease, then we can come and plateau somewhere here. Right, have you seen it? So that is that. So kindly take note. Okay, and we don't have to always start from 0. Okay, we can also start anywhere from here, as you can see. So look at how we can draw. We can even start anywhere from here and go. So we always don't have to start from the origin, this place, okay, or here. You can start anywhere. All right. You get the drawing concept? All right, so let's move on. Oh, okay. I think that is all. All right, I think that is all. I didn't add there. So that is all. Okay. So I don't have any slide again. That is all. All right. So any question for me? Any question for me, guys?
No, sir. No, please.
All right. So are you okay?
Yes, sir.
Are you sure?
Very sure.
Okay. Okay. So okay. All right. So let me just say something small about this. I won't teach, but I just want to introduce you guys to this. There you go. Okay. All right. So this is I'm supposed to make this one week 3 rather, not week 4. So yes, week 3 rather. Okay. So this is week 3. All right. So what I'm going to talk about the next time that we meet is going to be falsification. You need to falsify things. Okay. But there are a lot of concepts. How do you falsify things? Okay, which we are going to learn. We'll talk about a little bit of neural network, genetic algorithm. How do you falsify things? So once we now can represent our sets in a fuzzy way, we have to do falsification. Okay, that means we need to convert it from the fuzzy to what? To classical. So once you convert it to classical, we now do whatever computation we want to do. Then after that, we defalsify it. So we do defalsification. We need defalsification. That means you have to return back to the fuzzy form. All right. And that is what we are going to talk about. So the next time that we meet, we are going to talk about some of these things, and it builds on whatever we have done so far. Okay, it's going to build on whatever we have done so far. All right. So I'll send you guys work to do. Please, on Thursday when I come, I'll collect it. No excuses. I have to be honest. No excuses. So tomorrow or Sunday, please talk to yourself and let me know, because you have to meet for cardiovascular also. Okay, that 1 to 2 hours to catch up. So tomorrow or Sunday, let me know. See, tomorrow like this, Saturday, if you want us to meet in the morning, it's fine. In the evening too, is fine. Sunday, I know Sunday some of you go to church, so we can't meet in the morning. But in the evening too, be okay. So please discuss among yourself and let me know. Just 2 hours. As I said, I want to catch up with all the misses that I did. All right. So if I don't have any question, then I will